Let's start recording. Well, on the last lesson, we talked about loops, loop for, loop while, and this lesson, I want to consider with you some features, some main points of arrays. Arrays and connection of the arrays and pointers. We discuss about pointers and arrays. This topic is very important, and I plan to discuss with you about arrays and pointers two lectures, so this lecture and the next one. Well, first of all, let's consider again the diagram of all data types in C and C++. So all the data types are divided into basic two groups, built-in or basic types. These types are already defined and may be immediately used in your programs. And so-called derived types. Derived types, these types must be constructed by programmer. And one of these very important types is structured type array. When we use only the scalar type in the program, it may be not convenient for representing and processing large data. Imagine that we should process 10 numbers. In this case, we can imagine that we can declare 10 variables, A1, A2, A3, and so on. But in the case when we need to process 100 or even 1000 elements, nobody can declare 1000 variables in the program. In this case, to avoid this situation, the C language suggests a special data type called array. There is no strict definition of array. I just can try to explain it. Array is a set of data of the same type, which have a common name and are differed in location in the set and in the system of numeration. The main points from this explanation are that this set of data has the same type. Elements of this set have the same type, because in other data types, in other set of data, elements can have different types, but in the array, all the elements have the same type. And moreover, all these elements have a common name. Just one name for all the elements. But how to differ the elements in the set? To get access to the elements, we use the number of the element. In programmer, often we call it index. Array elements occupies continuous area in memory and are located successively one after another. Well, of course, you already use element arrays on practice, but on lectures, we consider some features of arrays. That's why I start from the very beginning. How to declare an array? For this purpose, we use a special operation denoted with square brackets. This operation is used in declarative statement, where type is the type of the elements in the array, ID is identifier of the array, and integer constant num is number of the elements in the array. So the usage of square brackets in declarative statement means that this identifier will be considered not as an ordinary variable, but as the array of the elements of this data type. When we declare a variable in a program, let me show you this example. For example, variable a. We declare it without any additional signs after the identifier of a variable. Even we can write a initial value, but when we use square brackets after the identifier, it means that it should be a constant. It should be an array. Here, R is an array of 10 elements. Or I can use I can use here any identifier that I want. Well, M, P, Q, C, any identifier. But if when I use square brackets after identifier, it means that I declare an array. All the array elements are numbered with integer numbers from 0 up to num -1, where num is number of elements in the array declaration. So the first element always has number 0, and the number of the last element depends on the size. For example, in this case, the first element has the number 0, and the last element has number 9, because the total number of elements is 10. For getting access to array elements in order to perform computational operations with it, we used again square brackets. We use the number of the element enclosed in square brackets. So you can see that the meaning of square brackets is different according to the place where you use it. When you use square brackets in declarative statement, it means that you declare an array. But when you use square brackets in executive statement, it means that you get access to the element of the array with a specific number. So when you write, for example, here M2, it means that you get access to the element of the array M with index 2. And after that, you can apply any operation to this element, and you can work with this element as with an ordinary variable. You can read from the keyboard values to this array cell. You can output this cell to the screen. You can assign some values to the cell and so on. But pay attention that compiler doesn't check the range of the indexes. If you try to use the index of the element that is larger than the size of the array, compiler doesn't output your mistake or error or warning. It outputs you, okay, succeeded. But when you try to run this program, you can get unpredictable result. So to check the range of the array element, it should be done by programmer. You should always remember that when you work with array, the numbers of the elements are from 0 to size -1. And if array mass has 10 elements, then the index of the last element is 9. And when you write mass 10 in the program, it will be a mistake. Let me show you some example. First, as far as the array consists of several elements, we should operate with this array element by element using its indexes. How to assign the values to array M? For example, I can do it like this. For example, imagine that I want to assign 2 for all the elements of array M. And I can write it manually. M0 equals 2, M1 equals 2, and so on. And so on. And the last line, it should be M9 equals 2. Of course, it's not convenient. Imagine that the array has not 10 elements, but 100 or 1000. In this case, the good solution is to use loop 4. Loop 4 with a loop counter I that starts from 0, I smaller than size of the array. Now the values of the index I will be in the range from 0 to 9 and will be increased by 1. 0, 1, 2, 3, 4, 5 up to 9. And here in the loop, I can get access to the array elements successfully one after another using this index. Okay, And after that, I can write another loop that outputs the elements of the array to the screen. These elements can be output using the operator cout, like ordinary variables. When I run this program, what will we see on the screen? We will see 10 numbers 2 without spaces between them. Yeah, and it looks not like different elements of the array, but as one large number. Let's insert a space between these numbers. To do it, I should add a space in the end of the cout statement. Let me run this program again, and I will see the sequence of 10 numbers 2 in the screen. Well, I can put here any initial value that I want. For example, I+1. In this case, the elements of the array will have the values from 1 to 9, from 1 to 10, sorry. And we will see it on the screen. Well, it's just an example of maybe two very simple operations. How to assign initial values to the array and how to output their values to the screen. Well, according to the array rules of the array declaration, the size of the array, it must be a constant. So if I declare a variable, for example, integer variable size with value 10, I cannot use the variable as the size of the array. The size of the array in the declarative statement, it must be a constant. So when I write here const qualifier, the program becomes correct. Well, and to use a constant, it's more convenient to use a named constant is more convenient than to use unnamed. Imagine that I want to change the size of the array here from 10 to 20. What should I do if I use a unnamed constant? In this case, I should manually rewrite all their sizes from 10 to 20. Here, 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 and in any place in the program. Of course, in this simple example, there are only 3 lines where I should change 10 to 20. But in the large program, it may be 10 or 20 lines. In this case, it's more convenient to use an unnamed constant. Let's use unnamed. Sorry, named constant with a name, size. Let's use size here. In this case, when you use a special identifier as the size of the array, it's enough to change the value of this constant, and all of the sizes automatically changes in the rest of the program. Let's check. Now size equals to 10. But when I change it to 20, it automatically changes, and we will see on the screen the sequence of the numbers from 1 to 20. Okay. Now let me come back to the presentation. And let me say a few words about initialization. When we declare an ordinary variables or a constant, we can assign initial values to the variables or constants. And the same can be done for the arrays. I can assign initial values to the array at the moment of its declaration. But when you assign the value to the variable, there is only one. There is only one value that you should assign. But when you assign the value to the array, there are a lot of elements that you should assign. How to do it? In this case, you should use a so-called initialization list. Elements of the array may be written in figure brackets separated with commas. For example, so here we see the array days, 12 numbers, 12 integer numbers in this array, and this array contains the days in the months of the year. And here, initialization list 31, 28, 31, 30, 31, 30, and so on. Let me copy this array to the Visual Studio, and it's okay. After this declaration, you can use the array days, and these values will be written to the elements of the array as initial values. But what happens if the initialization list is shorter than the number of the array elements? In this case, the first elements are initialized with the values from the initialization list, and the remaining elements are initialized with zeros. Let's check it. Suppose that I want to declare the array M of size 20, but I write only 3 elements in initialization list. Now I delete this loop and I use only the loop that output elements to the screen. What happens? The first elements, or let it be 10, not 20. The first elements will be 1, 1, and 1, and the last elements of the array M will be zeros. Initialization list is a good opportunity to assign initial values to the array in some examples. Let me write here 2 more values, 2 and 2. Now there are 5 initial values, 1, 1, 1, 2, 2, and the last elements are zeros. But if the size of the array will be smaller than the number of the elements in initialization list, it will be considered as a mistake. And Visual Studio outputs you the message, the corresponding message, too many initializers. So you will use too many initializers in the initialization list. Initialization list is larger than the size of the array. Okay, let's come back to the size 10, and in this case there the array will have first elements 1, 1, 1, 2, 2, and the last elements 5 zeros. Well, and let me show you one more possible mistake that you should avoid in your programs. Suppose that the size of the array is 10, but suppose that you write here not 10, but 15. First of all, let's try to compile the program. When we compile the program will be succeeded. So compiler doesn't check the range of the array elements, and it outputs you OK, even in the case when the index of the element is larger than the size. And what happens when we run such a program? You will see some random numbers on the screen. When you try to output these elements, you will see some random numbers. And the more or less the same situation happens if you try to assign something to the element with the index that is larger than the size of the array. Again, the size of the array is 10. The last index is 9. But this line, I try to assign element 10 to the array element with index 10 that is larger. And when I try to do it, the program outputs me a mistake, but not a not a mistake, not an error of compiler, but the mistake that occurs in the course of program execution. So this mistake happens when you try to write something to the array element with a larger index. Well, sometimes you can declare an array without explicit indicating the number of the elements. In this case, the number of the elements is considered to be equal to the number of the elements in the initialization list. In this example, I declare the character array code without indicating the size, but the size will be equal to the number of the elements in the initialization list. So the size will be 3. And the same I can do with any array. I can declare integer array m, and now the size of the array will be 5, the number of elements in initialization list. I can declare the array days, and the size of the array will be equal to the number of elements in the initialization list. Compiler computes it automatically. But is it possible to compute the size of the array, the number of elements of the array manually? The answer is positive. The answer is yes. Yes, we can compute it. To compute the size of the array without when the array will be declared without explicit specification of the size, we can use special operator sizeof. And to explain how sizeof works, let me switch to another presentation, pointers. And let's consider this first slide. Let me remind you that any information object, variable, constant, array, any information object, occupies several cells in computer memory. And the number of these cells, in other words, the number of bytes for the variable or constant, can be found by the operator sizeof. Sizeof returns the number of bytes required for storing variable, constant, or the data type. You can use a data type as an argument of size of. For example, how many bytes is required for storing data type char? To get it, we should call size of char, and the answer will be 1. Size of int 4. Size of double 8. So you should not you may not remember the number of bytes because you can always find it using operator size of. Let's check it. Let me show you this example. For example, let's output size of int. How many bytes required to store integer number? To find it, I can call size of int. Let's just as example find size of double, and size of double it should be 8. Yeah, right. Size of int is 4, and size of double is 8. But I can use here not only the name of data types, but name of the variables or constant. For example, size of size. Size is integer constant. That's why the size of size in this example will be 4. And we see again 4 in the first line. Well, in this case, I can compute the number of bytes. Number of bytes that requires for storing the array. And to do it, I can use size of and identifier of the array. Size of days. What will we see on the screen? We will see 84. There are 12 numbers. Each number is int. Int, size of int is 4. So the number of bytes required for storing this array is 24. And using this operator, I can compute the size of the array. Size of the array is number of bytes for all the array over size of one element of the array. Size of days over size of int. And it will be 12. So using this construction, size of array over size of element of the array we can find the size of the array, the number of elements, even this number is not specified explicitly. The same example is written here. Here, the type of the elements in their array code is char. That's why to compute the number of elements in this array, I should use the size of code over size of char. Well, the next point that I want to talk about is pointers. Pointers and connection between pointer and array. We have just a few minutes at the end of the lesson. And how many students are there? 3 students. Well, 3 is more than 1. Very good, but of course it's not enough. Well, I think we start this topic at the next lesson. So today we consider arrays, and the next lesson we will talk about the connection between arrays and pointers. We'll talk about what is a pointer and what is the relation between pointers and arrays. And in the end of the lesson, maybe let me show you one simple example, one simple algorithm that can be applied to the arrays. Let's use the array M. Let me assign some elements. Something like this, and the rest of the array will be zeros. Here I output these elements to the screen. Okay, and the task is how to find the largest element in the array. Of course, you can look to this array and see, okay, the largest element is 7, but how to do it automatically? Let's declare a special variable L for the largest element. And the initial value for this L will be the first element of the array. After that, I should repeat this loop. But in the loop, I should compare the current element of the array. So the element with index I and the element L. If the current element is greater than L, then I should update L. I should update the values of L. And after that, the largest element will be L. The largest element is 7. Again, first I assign I suppose that the first element is the largest element. And after that, if the current element is greater than this one, I update the value of the element L. Well, the largest element is 7, but what is the position of this largest element? What is the position? How to find the position? Let's introduce additional variable position. Initial value of the position will be 0. And in the case when I update L, immediately I should update the position. What will be the position? Position is I. The index is I. Let's output the position. Position equals to. Let's recall that all the elements starts from 0. That's why I should add 1 to the position. And we will see that the position of 7 is 4. 1, 2, 3, 4. The element 7, the largest element, has position 4. Very simple algorithm, very simple, but at the same time, very important algorithm. Well, I think that's all for today. And next week, we will discuss about pointers and about connection between pointers and arrays. And the main feature of this connection is a possibility to declaration of arrays of a variable size. Because here the size of the array is fixed, is a constant. I cannot differ this size. I cannot change it in the course of program execution. Even only I can change it manually here, and I can recompile. I should recompile the program, but I cannot change this size without recompilation. But using pointers, we can do it. We can change the size of the array without recompiling the program. Well, that's all for today. Let me stop recording.